All right, let's get into it. We're going to talk about the one phase in every single AI project that's absolutely critical, but nobody ever wants to talk about it. Data preparation. Yeah, I know, it's not the glamorous part, but believe me, this is where the real work gets done. It's the heavy lifting that literally makes or breaks your project. You've probably seen this happen, right? You have a brilliant team, you've got these incredible cutting-edge algorithms, and the project just fizzles out. It falls flat. So what's going on? What's that hidden reason, that silent saboteur that trips up even the best AI projects? Well, it almost always comes down to one simple, brutally honest principle. You've heard it before. Garbage in, garbage out. It's like the oldest rule in the book for computer science, but I'm telling you, it has never been more true than it is right now with AI. Your model, it doesn't matter how smart or sophisticated it is. At the end of the day, it's completely at the mercy of the data you give it. And that's exactly why we need to talk about phase 3 of the CPMAI methodology. Welcome to data preparation. This is the official, structured answer to that whole garbage in problem. This is where we stop being data hoarders and start being data craftsmen. We're not just collecting it anymore. We're actively shaping it into something truly valuable. So the official definition says this phase covers all the activities you need to build the final data set. And I really want you to focus on that word construct. This isn't just about cleaning up a messy spreadsheet. No. This is a full-blown construction project. We are literally building, transforming, and engineering our data until it's in the perfect shape for our model to learn from. Okay, so how do we manage all this work in a way that isn't totally chaotic? Well, that's where our hero comes in. We need to build what's called a data pipeline. And this isn't just some boring process, okay? Think of it as the powerful engine that takes all that raw, messy, chaotic data and reliably turns it into a pristine, model-ready asset. The absolute best analogy for this is a factory assembly line. Seriously. Your raw materials, that's your data, they come in on a conveyor belt on one end, then they go through all these standardized, automated steps, stamping, cleaning, shaping, and out the other end comes this perfect, finished, high-quality product. That's what a data pipeline does. And here is the key, the absolute most important part. A data pipeline is a repeatable process. This is not some one-off script you run just once and then forget about. No way. It's a fully engineered system. Its entire job is to guarantee that every single piece of data, I don't care if it's from a year ago or a second ago, goes through the exact same quality control steps every single time. And that brings us to maybe the biggest takeaway of this entire phase. You can't just build one pipeline. The whole point is to create reusable data pipelines. Specifically, you need the same pipeline in two different places. One for when you're training your model, and another one for when that model is out in the wild doing its thing in the real world. So why does this matter so much? Well, think about it. Your training pipeline, that's the one that takes all your historical data and uses it to teach the model what to look for. It's like the model's school. Then you have the inference pipeline. That one takes brand new live data and gets it ready for the model to make predictions on. It's the model's real-world job. Now, what happens if the school teaches you one thing, but the job expects something totally different? Exactly. It's a disaster. If those two pipelines aren't identical, the model will get confused and its predictions will be completely unreliable. Consistency is everything. All right, so now that we know why we need a pipeline, let's talk about what actually happens inside it. Let's pop the hood and take a look at the data cleansing toolkit. These are the essential tools you're going to find in any robust pipeline. We're going to look at a few key operations here. Things like getting rid of duplicates, making sure our numbers are on the same scale, and, of course, protecting people's privacy. We'll kick things off with de-duplication. So, first up, de-duplication. The problem here is pretty obvious, right? If you have the same customer listed, say, 3 times in your data, your model might think you have 3 customers instead of 1. That can seriously mess up its understanding of the world. So the solution is simple but crucial. We need a process that automatically finds and gets rid of those duplicate records. We want to make sure every single person or thing is counted exactly once. Okay, next on the list is normalization. Now this one's a little trickier. Imagine your data set has 2 columns, a person's age, let's say 45, and their annual income, let's say $90,000. To a lot of AI models, that $90,000 looks way more important than the 45, just because it's a bigger number. The model gets biased. So normalization fixes this. It basically puts all your numeric data onto a standard scale. like from 0 to 1. That way, the model can look at both age and income fairly without getting distracted by the huge numbers. And this next one, this is a big one: anonymization. Your data is probably full of sensitive stuff: names, email addresses, phone numbers, all that personally identifiable information, or PII. Anonymization is the process of stripping all of that out. Why? To protect people's privacy and to comply with regulations like GDPR. Honestly, in today's world, this isn't optional. It's a non-negotiable step if you want to build AI that people can actually trust. But wait, there is more. Data prep isn't just about cleaning up the messes, It's also about making your data even better, even more powerful. We can do that by enhancing it and, in some cases, labeling it. Yeah, we can actually make our data smarter. For example, we can create what are called derived attributes. If you have length and width, you can create a new area column. Boom, new information. We can also generate records to fill in gaps. Let's say you had 0 sales on Tuesday. Instead of just having a blank spot, you create a record for Tuesday with a 0 in the sales column. That's useful information. And of course, we can merge data, pulling in information from different databases to create one big, rich, super informative data set. And we can't forget about data labeling. For a huge category of AI called supervised learning, this is absolutely essential. This is where we go in and add the right answers to the data. Telling the model, this image is a cat, this one is a dog. It's how we give the model a study guide, the ground truth it needs to learn from. So let's put it all together. You can see the whole journey right here. We start with raw, messy data. It goes into our phase 3 data prep pipeline. And what comes out the other side? A beautiful, clean, enhanced, and perfectly labeled data set. And that golden data set becomes the input for phase 4 model development. We've totally set the next phase up for success. So look, if there's one thing you take away from this, it's that we have to change how we think about this work. Data preparation is not janitorial work. It's not some boring chore you give to the intern. It is foundational engineering. It is the disciplined, critical, structured work that makes all the cool, powerful, reliable AI stuff even possible. So I'll leave you with a question to chew on. Think about this. A really well-built data pipeline can be used to train dozens of different models, now and in the future. But a brilliant AI model that was trained on garbage data, it's completely worthless. So which one is actually the more valuable asset to your organization in the long run? The model or the pipeline?